Hello and Assalamualaikum. Today I am going to present about the engineering practice uh, lab 2. We are from section 4 group 9. So firstly I will introduce my name. My name is Nurul Atika Binti Mahfudri and my message number is E18056. My middle name is Nurul Anis Binti Abdul Aziz E1800101 and my friend transaction AE190100. So I will explain about the figure 7.11. So here is the figure 7.11 after we run and we online the figure. So in question 11, S1 and S2 are connected in series. From this network, S1 and S2 are in nominally closed condition. When S1 and S2 in the nominally closed condition, the input on off will be opposite. Therefore, when S1 and S2 are equal to 0, output Y0 will exist. So here, in this mnemonic function for contact S1, contact S2 and output Y0. So, when contact S1 is 1, when contact S2 is 0, the output will be 0. Uh, when contact S1 is 0, contact S2 is 1, we also get 0 because there is no current flow in this circuit. So when the contact S1 is 0, contact S2 is 0, the output will on because there is current connecting in the circuit because when S1 S2 is equal to 0, output will be active. So lastly, if the contact S1 is 1 and contact S2 is 0, the output will not active or 0 because there is no connection in this circuit. Okay, after that.
Hi, Assalamualaikum. My name is Nuranis and I am from section 4, group 9. I will explain to you question number 7.1.2. So here is the for the network 1 for question 7.0.2. So when we click on the online mode button and then we click on. So we put our X1 and X2 according to this table. 0 means the force is off. Also here for X2, force also off. So XY is also off. Then for another input is X will be off. X1, X2 will be on. But XY is Y0 is still off. So it become 0. For another step is X2 will off, X1 will on. But the same output, it will become 0. And lastly, according to this truth table, X1 on, X2 also on, and we will get Y0 is on. So here is for the network 1. After that, we will continue for the network 2. Next is for network number 2, and I will do this network according to this two table that I already did. So X3 we put as off, X4 as on, X5 on. So we get y1 is 0. For the next example, we put x3 as on, x4 off, and x5 also on. So we get y1 is 1. And lastly, for the last example, we put x3s on, x4s on, and x5 also on. So we will get y0, y1 is off. So next, we will proceed to next question. Next is for question 7.1.3. So here is the truth table, and I will show some example according to the truth table that I already highlight. So, for example, x1 is 0, x2 also 0, off, x3 off, x4 off, and x4 on, x5 off. So you can see here, this is bar. So when this is bar, when we put the input as off, it will turn on. And when we put 1, it will turn off. So the result we get is 0, 0, 0, 0. Next, for example, next example is this one. So we put x1 as 0, x2 as on, x3 as on, x4 off, x5 off. Is the same result. Y1 and Y0 still off. And for the last example, we put x3, x1 on, x2 on, x3 on, x4 off, x5 off. So you can see here, we get the output for y0 and y1 is on. So we continue for the network number 2. Next is for network number 2. As you can see here, this is the truth table for network number 2. So we put x6s off, x7s off. We will get y2 off. Then we put x6s off, x7s on. We will get y2 on. Then we try for the next example is x6 will be on, x7 will be off. So there's no output. And lastly, for the post, X6 will on and X7 also on, Y2 will become 0. So this is the solution for question 7.1.3.
In question 7.14, x1, x1, x2, x5, x6, x7 are connected in parallel. From this network, x1, x3, x4, x6, and x7 are in normally open condition, and x0, x2, and x5 in normally closed condition. Therefore, when XO, x2, x3, x4, x6, and x7 equal to 1, and x1 and x5 equal to 0, output y not will exist. So in this mathematical function table here, show when the contact SO is 1 and contact S1 is 0, contact S2 is 1, contact S3 is 0, contact S4 is 0, contact S5 is 1, contact S6 is 0, contact S7 is 0, and the output will get 0. Or because there is no current flow in the circuit. So when the contact S0 is 1, contact S1 is 1, S2 is 1, S3, S4, S5, S3 and S4 is 0, S5 is 1, S6 is 0, X7 is 0, the output will also get 0, so will not exist 2. Will not exist 2. So when the contact X0 is 1, contact S1, S2, S3 is also 1, contact S4 is 0, contact S5 is 1, contact X6 dengan X7 is 0, the output will get 1 because here is the connection is in parallel. So when X3, X5 is connected or on, the circuit will be on because there are current flow in the circuit. So plus D when the contact X0 is 1, contact S1 is 0, contact contact S2 is 1, and contact S3 is 1, contact S4 is also 1, contact S5 is 0, and contact X6, X7 is 1, so the output will get on and active. So there is current flow in this circuit because there is open connection. So because the connection is in closed condition, so the output will be on. Okay, that's all from me, and I pass to another member to continue our presentation.
Recording in progress. A very good day I would like to wish to Doctor. My name is Tang Jiaxian and my matrix number is AE190100. So in this video presentation, I'm going to present the part 7.2, 7.3 discussion and together with the conclusion. So the question for 7.2 is, what will happen if the user did not click online mode when executing the program? So first of all, let's understand what is online mode. So there are many communication functions that can be found in ISP software, for examples like run stop, upload download, and device monitoring. So online mode is one of the communications functions that can be found in the ISP software. So the function of the online mode is to connect to PLC and enter monitoring mode, and the editor will become read only after the online mode is on. So in order to understand what will happen if the user did not click the online mode when executing the program, we have tried to execute a program which can be found in the lab sheet when the online mode is remain as off. So this is the program that we construct by using the software according to the one of the example given in 7.1. So as you can see, the contact X0 and X1 is normally closed, and Y0 is the output. So in this case, when we run the program, we are supposed to get the results which the output is on. So in this case, I'm not going to click the online mode and I will run the program directly. and which you can see that the program is already executed, but the status remain as offline. And as we can see, there is no result shown after we have run the program without clicking the online mode. So we can see that the program is running, but the status is shown offline. So the output and the context are not reacting at all after we have run the program. So in conclusion, we can conclude that there is no result and changes when the program is run if the online mode is not on. So now let's move into 7.3. So in 7.3, we are required to modify the figure from question 7.1.3 so that the lamp Y0 and Y1 will always on. So according to the question 7.1.3, we have constructed the program in ISP software as shown in figure below. So now I'm going to show the program that we construct by using the software. So this is the program that we constructed by using the ISP software. So as you can see, according to the figure 7.1.3, the contact X1 and X3 and X7 is remain as normally open, while X2, X5, X4 and X5 and X6, X12 remain as normally closed. Therefore, as we can see that the contact X4 and X5 is connected parallelly to contact X2 and X3. Therefore, in this case, if the current is able to pass through X1, it will go directly to X4 and X5 and all the way reach the output Y0 and Y1, so that the output Y0 and Y1 will be on. Therefore, in order to achieve that, we are going to modify the program by changing the status of the contact X1 to from normally open to normally closed, which the current will be able to flow through from X1 and reach X4, X5 and all the way to Y0 and Y1. So now I'm going to run the program to prove that our modifications is success. Alright, so as you can see, the output the lamp Y0 and Y1 is on after we run the program. So given that the contacts X4 and X5 are normally closed, which allow the current to flow through the and connected as parallel, which can bypass the contact X2 and X3. Therefore, we can simply make the lamps Y0 and Y1 always on by changing the contact X1 from status of normally open to normally closed. So as we can see, the lamps Y0 and Y1 are always on after we have changed the status of contact X1 from normally open to normally closed. So in discussion, so in 7. For discussion, in 7.1, we run the program with different sets of conditions according to the truth table. So given that the current will not be able to flow through a contact when the contact is at the status of normally open, whereas the current will be able to flow through when the contact is at the status of normally closed. So as shown here, so as you can see, if the contact is in the status of normally closed, the current will be able to flow through. But if the contact is at the status of normally open, the current won't be able to flow through. So when the truth table shows the contact is 1, it means that the contact is activated, which will change the status either from normally open to normally closed or from normally closed to normally open. While the truth table shows whereas the truth table shows the contact is 0, the contact is not activated, which the contact will remain at current status, which if the current status is normally open, it will remain as normally open, or if the current status is normally closed, it will remain as normally closed. So in 7.2, we are required to observe what will happen if the users did not click the online mode when execute a program. So in our observation, the program did not provide any result or output when the online mode is not on. Since the function of online mode is to connect to PLC and enter the monitoring mode, therefore we are not able to connect to PLC and enter the monitoring mode when the online mode is not on. So no result and output will be shown after we execute the program without the online mode on. So in 7.3, we can see that the contacts X2 and X3 are connected with contacts X4 and X5 in parallel way. So this is the connection. As we can see that this is a parallel circuit. So the contacts X4 and X5 are in the status of normally closed, which allowed the currents to flow through, whereas the contacts X2 and X3 are in the status of normally open, which the only the X3 are in the status of normally open and X3 is in the normally closed, which the current will be able to won't be able to flow through the X3. So as we mentioned earlier, the contact X4 and X5 are parallel to the contacts X2 and X3. Therefore, contacts X4 and X5 can bypass the contacts X2 and X3, which allowed the current to flow through X4 and X5 all the way reach the lamp Y0 and Y1. So in this case, we just need to modify the contact X1 by changing the status of contact X1 from normally open to normally closed, which allowed the current to flow through the contact X1 and reach the contacts X4 and X5 to reach lamp Y0 and Y1. Therefore, the lamp Y0 and Y1 will always on after we have modified the contact X1 to normally close. So we have proved that with the demonstration just now. So as you can see, when this is in the status of normally closed, the current flow to X1 and to X4, X5, and all the way reach the output. Therefore, Y0 and Y1 will always on. So conclusion. So in this lab 2 of MRIB, we are introduced to PLC programming using the ISP software. Therefore, we are getting the opportunity to get familiar with the techniques to programs PLC using programming ISP software. So programs PLC stands for Program of Programmable Logic Controllers, which is an important task of designing and implementing control application depending on customer needs. Therefore, PLC programming is very important for us to master in order to become an engineer in future. So at the same time, we are given the opportunity to build some PLC programs, run and troubleshooting. So we are appreciate that we are given the opportunity to be involved in the practical practice. So that's all from us. Thank you very much.